Hello, my name is Christian Iserland. I'm working in the marketing at METTLER Toledo. And today I would like to present you our portable density meter, the Densito. As you can see, I'm not wearing any lab coat, any gloves, any goggles, because this is just for presentation. As you can see also, I brought another device, which is called a Pycnometer. And this is still widely used in many labs. And I want to show you with a quick video how to use it so that we can compare it with the Densito afterwards. This video shows how to measure the density of a sample with a Pycnometer. So first you have to fill the sample into the Pycnometer. Then you have to add the capillary stopper, and you can see that some sample comes out of the capillary stopper. So these has to be wiped off to make sure that you have nothing left. And then you put the Pycnometer into the thermostatic bath. You will have then to wait approximately 30 minutes until the sample has reached temperature. So if the capillary is not completely full, you will have to add some more sample. Then you have to wipe off drop of samples which have been remaining. We remove then the Pycnometer, and you have to clean it thoroughly to make sure that there is no sample outside of the Pycnometer. So you clean it and dry it to make sure that the Pycnometer has nothing left on the outside. You will then weigh this Pycnometer on a balance. And once you have got the result of the weight, you get then by calculation the density, which is here 0.92574 gram per cubic centimeters. Now that you have seen the manual measurement with a Pycnometer, let's move to digital measurement with our Densito. So now I would like to show you how the Densito works. So we have here a sampling tube. That sampling tube allows the sample to get into the measuring cell. And this measuring cell is made of glass, and it's put into vibration. So this is oscillating. And when you put the sample into this measuring cell, it will lower the frequency of that measuring cell. So the higher the density of the sample, the lower the oscillation. And in order to get the sample into this measuring cell, we have a sampling pump, which is actually a piston pump. And this piston pump is activated by a joystick. And this joystick allows them to do the sampling. So for example, here, when I press up, you can see that the piston pump goes up. And if you press down again, then the piston pump goes down. So now I would like to show you how to measure a real sample. So I have to take the tube into the sample. Then I do a sampling. And because I don't know what sample was in there before, in the Densito, I will do some analytical rinsing. So I put that into the waste, and I will do 3 times the sampling. So this is the first sampling. Now I do a second sampling, which will also go into the waste. And now I do a third sampling, where I will start the measurement. Then we start the measurement by pressing the start key. And the measurement will take approximately 10 to 15 seconds. And when the measurement is done, we have a blue background screen, which is shown here. And we have the density result. But if you look now at the screen, we see that the sample temperature has been at 27.1. So this is a real sample temperature. But on top, we see a result. It's called decomp at 20 degrees. So this means this is a compensated density value at 20 degrees. So how can we do that? So in order to do this temperature compensation, we need to set it up in the method. So this was the method density. And as you can see here in the method, we have a calculation of decomp. So we have set the measurement to be compensated at 20 degrees. We see that this is the compensation temperature, so that the temperature at which we want to have the density value. It could be also 25 degrees or 15 degrees. And in order to calculate that, we have an alpha value. This alpha value is known for most of the products. So you just have to enter these alpha values. But if you have a sample, if you don't know the alpha value, you can actually calculate it with a Densito. In order to do that, you would set up the temperature of the sample, let's say a little bit below 20 degrees, so maybe 18 degrees. You would measure then the density. And then you would warm up the sample a little bit above 20 degrees, so maybe 22 or 23 degrees. And then out of these two values, you can calculate the alpha value. If you compare now the two measurements, so the one with the Pycnometer, which is a manual measurement, to the one with the Densito, which is a digital measurement, you can see that there is a big advantage of using such a digital density meter. The first advantage is the time. As you could see in the video, it takes over 30 minutes to thermostat the sample, so the whole measurement takes a bit more than 30 minutes, maybe 32 or so. While it's much faster, just a few seconds with the Densito. Why is that? Because we use these temperature compensation, so we don't have to thermostat the sample, which you have to do with the Pycnometer. Now, another advantage of this instrument, it's because it's always done in the same way. Digitally, you get a very, very high reproducibility. While you don't get that with the Pycnometer, because with the Pycnometer, you have different operators, which might get a bit different results. So you get a much higher repeatability with the Densito. So now we'd like to show you another application of the Densito, which can be used also for quality control. And in this example, I've selected orange juice, and I want to show you how to make quality control on orange juice. So we will run the quality control on the first orange juice. Here I do a first sampling. So again, I need to do analytical rinsing. So I do a first rinse with that sample, and I empty it into the waste beaker. And finally, I do the final sampling where I can start the measurement. You have to press start to start the measurement. And then you will get the result. Here it's marked in green, which means that the quality control has passed. And I have now selected another orange juice, which has been slightly diluted, so to show you what happens when the sample doesn't meet the requirements. So we do again these sampling with analytical rinsing. And now the final sampling with the diluted orange juice. Then you have to press the start key to start the measurement. And after a few seconds, you will get the result. And we see here that the quality control has failed. So once you have done these measurements, you can go into results to see your measurement results. Here you see that we have the last two measurements. One is green, which was the orange juice, and one is red, which is actually the diluted orange juice. And you can even access more detailed data by going with the joystick on the right, and then you have some additional information which are shown here. I would like to show you now another application, which is a so-called guided workflow. So what is a guided workflow? it will actually lead you through all the different steps required to measure with a Densito. I have set up a method called guided workflow. So I just start now this method, and it asks me to enter the sample ID. So usually you would enter the sample ID manually. But here we have an RFID tag, and we have an RFID reader, so we can just enter the sample ID with the RFID reader. Then it asks me immerse tube into the sample. So I go into the sample and I press OK. It does now the first filling of the measuring cell, and we are going to do actually 2 analytical rinsing. So it asks me then empty solution into waste. So I go into the waste and I press OK. And what it does now, it just empties the measuring cell into the waste beaker. Then I read there, it asks me to immerse the tube into the sample. So I go in there again, I press OK. Now it fills the measuring cell again, so we do the second analytical rinsing. And it tells me empty solution into waste, so I go into the waste, and it drains now the measuring cell into the waste. So we have done now 2 analytical rinsing, and it asks me then immerse tube into the sample, and here we are doing the final sampling for the final measurement. So once the measuring cell has been filled with a sample, the measurement is started automatically. So after 10 to 15 seconds, it gives you the results. And here we see that it has passed. And now it says connecting to printer. So it will now print out the data on the Bluetooth printer. If you use another printer which is connected, then you can also use a USB printer to get the data. And when it's done, you can then press OK. And it tells me empty solution into waste. So I go back to the waste, press OK. It drains now the measuring cell. Then it asks me immerse tube into cleaning solution. So now we do a cleaning cycle. So I go in there, I press OK. It does now fill the measuring cell with the water, which is our cleaning solution. Then it tells me empty solution into waste. I go into the waste and I press OK. So as you can see, we went through all the different steps of sampling, measuring, and cleaning with the Densito with this guided workflow. This guided workflow allows us to use this Densito as a one-button machine. Why? Because you just have to read what is on the screen, you do what is asked to do, and then you press OK. You read, you do what is asked to do, you press OK. So it's all done automatically and you cannot make any mistakes. That's the beauty of the guided workflow. Once you have used your Densito for quite some time, you would like to know if it's still working according to specifications. So what you would do then is test your Densito with some water standards. And actually the Densito comes delivered with water standards in form of a sachet. And I would like to show you now how to run this test. So the first thing we have to do is to select in the menu the test function. And here the test function is shown that we do with water and with a tolerance of 5 on the 4th digit. So once you have set up this test function, you will really start the test. But before that, we need to do again analytical rinsing. So what you will do is you will do again the analytical rinsing, but just now with standard water or deionized water. And so you would do that again twice. So a first analytical rinsing. Now you empty the measuring cell into the waste. Then you go and perform a second analytical rinsing. So you use the water and you clean the cell and you go into the waste. And now, once you have done that twice, you can go and run the test with the standard. So you will do then, you will open this water sachet Now you have to dip your sampling tube into the sachet and perform the sampling. Then we start the measurement. And now the Densito is measuring the water, and it's comparing then the water value with the target value of water at that temperature. So here we see the test has passed. I want to show you now another application. As you have seen before, we have measured different samples with the Densito, but there are some samples which cannot be measured by using the piston pump. This is because these samples are too viscous. So when you have samples which are over 1000 millipascal seconds, you need to use a syringe. And I want to show you how to measure these samples with a Densito and a syringe. So first of all, we have to put the Densito on the stand. And you see that when I turn it upside down, also the screen is going to turn upside down. I put these onto the stand. And we see that that stand has actually two functions. One is to recharge the Densito when it's put on there. And the other one is to be used as a stand for the measurement with the syringe. And I want to show you now how this works. So I have here a sample which is quite viscous. It's a syrup. And I will then put that sample into the syringe. And then I will go to the Densito and put the syringe in here. And slowly fill the measuring cell until it comes out of the draining tube. And then I start the measurement. So we get the result. And usually if you have some really difficult samples, like some creams or so, you might want to do a threefold measurement. So what we will do is you will press OK. Then you will add a bit of sample again. Then you will start the measurement. And we will now do a third measurement by pushing again a little bit the sample in the measuring cell. And we press the start key. So we perform now the last measurement. And here we can see in the results that they are quite similar. So we can say that this sample was not problematic and we could measure it correctly. The measurement is done, and then you would remove the sample from the measuring cell, and then you would go into the waste with your sample. And then you would use the syringe with water to clean up the measuring cell and the drain tube. So what do you do with all this data you have measured with a Densito? You can either print it out on a printer, a Bluetooth printer, which we have seen before. You can also print it out on a USB printer, which you would connect here to the Densito. You can export the data to a USB stick, or you can connect the Densito directly to the laptop, and then you have your data into our EasyDirect PC software, which I will show you now. Now I would like to show you what you can do with the data which we have measured with the Densito. This is the EasyDirect PC software, which can be used for different instruments. Here we have data from the Densito, we have data from the Densito Pro, and we also have data from the refractor. The refractor is our portable refractometer. We see the data which have been measured with the Densito Pro, and we see the colored information. So the green data has passed and the red has failed. If you look at the failed data, you can click on one of them and you will get some additional information on the results, but also on the method and on the serial number of the instrument. These data can either be printed. Here we have a selection on what we want to print. So if you want to just have the results, we select results only and we would print them, either on a connected printer or on a network printer. We can also export these data if you click on Export Analysis. You can choose which data you want to export. You can then export them in different formats as Excel or CSV file. What I would like to show you now is a chart function. Let me switch to data which we have measured with our refractor. We measured the Brix, which is the sugar content, of a sample over time. If we click on the chart, we see how the sample has changed over time. We see here the increase of Brix over time. So typically, we could use this chart function to monitor, for example, the fermentation of wine or beer over time. This first application is for hand sanitizers. It is based on the WHO recommendation for the local preparation of these alcohol-based hand rubs and describes the formulations to be used and how to use the Densito to test them. On the front page of this application, you can see the two formulations recommended by the WHO. One is based on ethanol at 80% with smaller quantities of glycerol and hydrogen peroxide. The second formulation is based on isopropyl alcohol at 75%, with the same quantities of glycerol and hydrogen peroxide than the first formulation. The Densito can be used to test the raw material's purity, which has to be 96% for ethanol and 99.8% for isopropyl alcohol. The back page of the application describes how to use Densito for the quality control of both formulations. The target value for the ethanol-based formulation is 80%. The limits for quality control have been set to 75% and 85%. For the isopropyl alcohol-based formulation, the target value is 75, which will show 77 on the alcohol scale, and the limits for the quality control have been set to 72% and 82%. With these limits, the Densito gives an immediate pass-fail information after the measurement has been done. Here is an example of an ethanol-based formulation with one result which has passed the QC and one which has failed. You can see from the measurement, which we have done in our lab, that the measurements are very consistent with our Densito. This application is for the beer industry. So one of the most important values in the brewing process is the sugar content of wort. And this application describes how to measure these sugar content and how to monitor the fermentation process of beer. The fermentation process typically takes 1 or 2 weeks. To monitor this process, the density or specific gravity is measured daily and converted into plateau, which is the sugar content of the extract in 100-gram wort. Using the Densito, the measured density is automatically compensated to 20 degrees centigrade and is displayed in degree plateau. You can see on this table and curve the decrease of the sugar content over time. This graphical evaluation can be done directly with our EasyDirect PC software. So the last application I want to show you is in the wine industry. Here you can see that we have the Densito with a protective cover and a wrist wrap. This is to protect the instrument in a rugged environment. Wine is made out of grapes, which are harvested and crushed and then put into tanks for 8 to 14 days for fermentation. And the Densito can be used to monitor the fermentation process of the wine. This application is about wine fermentation monitoring with our Densito. To monitor this process, winemakers measure density or specific gravity, usually once per day. Quite often, they still use hydrometers which are not so precise, and need some care to get accurate measurement. The Densito allows faster measurements, not only for the density value, but also for the temperature value. Using the Densito, the measured density is automatically compensated to 20 degrees centigrade and can be displayed in specific gravity, gram per cubic centimeters, or other derived values. In this example, we measured the specific gravity of the wine compensated to 20 degrees centigrade. The table and the curve show the decrease of the sugar content over time. The curve can be obtained directly with our EasyDirect PC software. I hope I could give you some good overview of what we can do with our Densito. So measuring different types of samples, even viscous samples with a syringe. Then the different types of workflow, the guided workflow, the quality control we can do with the Densito. Then what we can do with the data, put them on a printer, on a stick, or on a laptop, and finally show you some typical applications.